Welcome to Lecture 7.3, Custom Messages in ROS. The messages that come in the standard messages package should be exhausted before considering the specification of a new message description. A line-separated list, so this is what a message description is, a line-separated list of field type name pairs and constant type name value triples. For example, the following is a message description with two fields and a constant. The first two here are fields, so we have first a type and then a type name, so a field type and then a field name. So int32 is a pretty standard one from the standard messages, and we called it X. So this would say a message would contain an integer, a 32-bit integer, and we're going to call that X. Also, another field, a float32, so a floating point number, a 32-bit floating point number, and we're going to call that one Y. Okay, that's the name. And finally, we'll also do a constant, which we have to also give a value. So int 32 z equals, and then we would have to put in a 32-bit integer, so like 5 would be an example. So for a constant, we actually have a triple. We have first type, and then we have a name z, and then we have a value 5, and the syntax goes type space names equals value. So that one is constant, doesn't update every time. Okay. The field and constant types are usually ROS built-in types, which are shown in table 7.1. So we saw the int32 right here, and we saw a float32 right here, and this talks about how they get serialized. The C++ type, and then the Python type. So mostly Python 2 and 3 have the same interpretation here, but there are a couple differences here and there. So a lot of things to work with here. Of course, integers, floating point numbers, booleans, strings, ASCII strings, time and duration, which are two special ROS types. So in Python and C++, they're also custom as well. So those are the sort of types that we'll typically use when we create a custom message. And there are also other types that you can use, including custom ones, but we try to stick to the ones that are already defined, unless we have a good reason not to. So if you go here, you'll get the documentation for different ROS messages and the message definitions. And there's a lot of detail. A lot of times you only need to know a little bit to get started, and then when you need to do something more advanced, you might need to dig into the docs a little bit deeper. One thing I wanted to highlight, though, from the docs is that we can also, in addition to just having single fields that are like an integer or a float, we can also do arrays in a syntax that looks a little bit like C or C++. When you define an array, for instance, you can do a variable length array of integers like this. So the name would be foo, an array of variable length here. You can also do a fixed length array where you put the length of the array in there as a literal. Like if you had a 25 value array, then you would put in 25 in the brackets. So these arrays are interpreted in Python as tuples. So int32 arrays are interpreted in Python as tuples. So you can treat them as such when you're in Python using ROS.py, like we are. To use a custom message description, create a .message file in the subdirectory, the package directory / MSG. So you might need to create the subdirectory if it doesn't exist, and enter your message description into this MSG file. You also have to name it with the file or with the message type. So the message description file should be descriptive here. Good. An example message description. So we're going to do a little example here. We develop a custom message description complex in the msg / complex.msg file for messages with a real and an imaginary floating point number. So a real floating point and an imaginary floating point number. We continue to build on the package we've been creating in this chapter, My Topics, which shadows the package included with the book Rico Topics. The first thing when creating a custom message description is to create the message description file. Okay, so let's do that. First, from your package root, create it with the following. So you might need to create the MSG subdirectory if it doesn't already exist, and then we can create the file complex, which is going to be our new message type, custom message type, .msg. So let's go ahead and do that. We'll actually do this in parallel here. So if we take a look, we are in the My Topics directory, which is our package directory, and we see we've got an MSG subdirectory here, which I'm going to just trash and remake, just so you guys can see it. So now we don't have a message subdirectory, and if we would like to create one, we just make dir MSG, and then we can create the msg / complex.msg file with touch, and now we can edit the contents of complex.msg to include the following. So we're going to have a float32 real part and a float32 imaginary part, the two fields that we'll include here. So let's do that here. We can do Sublime text open. We can do any text editor though. MSG complex. And it's an empty file, so it opened up here in Sublime Text. We can do int 32, and we'll call it real, and we can do int, or no, float. We were going to do float, weren't we? We were going to do float. Let's do float. Float 32 real and float 32 imaginary. Great. Save the file, and you can close it too if you'd like. So now we've got our message definition. We got the file, and we are ready to update the build system. So the package we've been working on in this chapter, My Topics, was created with a bit of forethought. We included as dependencies in our catkin create package call the packages message runtime and message generation. Okay. If we hadn't had such foresight, we would have to make several changes in our packages, package.xml and cmakelists.txt files before proceeding to create our own message description. As it stands, we still need to make a few changes to them, so it's not too bad, and we'll just walk through. So first of all, how we need to change package.xml. Including message runtime and message generation in our cat can create package call yielded the following lines in our package.xml, which would otherwise need to be added manually. So if we hadn't done that, we would need to put these lines in. Let's go ahead and look at our package.xml file. So take a look at it. We've got down here at the bottom, we've got a bunch of dependencies, but the two that we were calling out, we would have had to add our build depend message generation and exec depend message runtime. So build depend message generation shows up here, this line, and exec depend message runtime shows up there. So we would have had to add those. But since we remembered when we were generating our package to include those two packages, they got inserted automatically into our package.xml. However, we still need to add message runtime as a build depend. So build depend requires this message runtime here. So we've got a few other build depends here, so I'll put it right below the others. Build depend message runtime. And if you forget to do this, you'll see an error when you do your catkin make that will essentially tell you that you need to add this as a build depend. So it's not the end of the world if you forget, because you'll be reminded. Okay, how we need to change cmake lists.txt. Including those two in our cat can create package yielded the following lines in our cmake lists.txt, which would otherwise need to be added manually. So we need to look at find package in cmake lists.txt. So let's close our package .xml, and that is this file, but I'll open it up again. So subl cmake lists.txt. And if we look at the find package block here, message generation is included here. It would not be included if we had not remembered to do that in our create package, cat can create package call. So we still have to do some other things, but that is not one of the things we need to do. The rest of the changes we do need to make manually. As an additional line in the catkin package block, we need the following: catkin depends message runtime. So this is the catkin package, so we'll scroll down to that. It's a little hard to see because we don't have any nice syntax highlighting here. Sometimes I just okay. Oops. There it is. Right here, line 106. So catkin package has here some things that are commented out. So what we'll do, you can leave those commented out parts if you like, and just add another line in here. And we need to add catkin depends message runtime. Catkin depends message runtime. Okay. You see that actually we have this in there as one of the catkin depends listed, but it's commented out by default, and it's there because we included it in our catkin package or create package. And so we could just comment this line, and then we probably could get rid of the others because they're not required to be there. So great. The add message files, so moving on to the next one. The add message files block needs uncommented and edited to appear as follows. So add message files is next. Add there we go. Here, line 51. So we need to uncomment this, which your text editor probably won't see this as something you can uncomment without manually taking out those pound signs. We can uncomment it, and these are just there as placeholders. Files we do need, but then we need to put in the file that we actually created, which is complex.msg. So complex.msg. Great. Save it. We have one more thing to do. Finally, the generate messages block needs to be uncommented such that it appears as follows. We don't actually have to edit this one. Just under generate messages. So generate messages, we can simply uncomment this block. Great. Save it up. And that is all we need from that cmakelists.txt. So now our package is set up to use the message type complex, or it will be once we catkin make our workspace. First, before we catkin make our workspace, let's write a simple publisher and subscriber to try it out. So writing a publisher and subscriber. So we can now write these nodes that publish and subscribe to messages with type complex. Create, using touch, a Python node file, changes permissions to user executable, and edit it to have the same contents as the message publisher node that comes with textbooks, a Rico Topics version of this, shown in figure 7.3. So this is the file. Some usual stuff at the top of it here. ROS.py. Notice that we have to import our custom message type into the Python file. So this comes from our Rico Topics package, the .message directory in it, and we import complex. And we're also going to just randomly, we're just going to print out random numbers, random complex numbers in this example. So we're going to import random, the random package as well for Python. Okay, so ROS.py.init node, to initialize our node, we'll call it message publisher. Pub equals ROS.py.publisher. This is how we register a topic. So we'll use the topic name. Complex could be anything, but we'll call it something reasonable like complex. The message type. Now here's where we actually are using what we created, which is that complex message type. And we'll use a queue size of 3. Not too important. We can have a low queue size here. Rate, ROS.py rate, we'll set it to 2 Hertz. And we'll do a little while loop that says while we have not shut down this node, we will loop through here. We will create a message of type complex. Okay, so there is a little caveat here. We could create it with We could create it in another way, which I'll show you here on the side. We could write MSG equals complex, and the constructor here in Python allows us to include either as an ordered pair, so real came first, then imaginary, in our description, our message description file. So we could put the real number first and then the imaginary number, or we could use named arguments, so real equals, and then we could give it some floating point number here, and then imaginary equals, and then give it an imaginary number. So you can actually when you create your complex object, you can construct it with real and imaginary values. Here, I instead constructed it with the constructor empty, and then I later assigned random numbers, so random and random give me random floating point numbers, and assign them to message.real and message.imaginary. So you can assign values that way too. Those are the two different options. And then we'll publish, so we set up our pub up here, so we'll call the publish method and give it the message that we just constructed, and then we'll sleep to keep this 2 Hertz rate going for our while loop. So it's going to publish at 2 Hertz random real and imaginary parts of a complex number in our custom message, or our custom complex message type. Okay. So that's that node. The other node that we're going to make is just a subscriber to that topic. So once again, we have to import complex from Rico topics.msg. In our callback function, we're going to print. This is a nice thing to do. So we'll initialize our node. We'll call it message subscriber. We'll subscribe to the complex topic, and we know, of course, it's a complex field that we're going to be looking at, a couple of fields. And callback is the callback function here. So every time it receives a new value, so at about 2 Hertz, we'll have the callback function called, and we'll print out the real and imaginary parts, and then a blank line here. So this is just empty. And then we'll just keep this node running until we shut down. So that's a pretty basic and similar to our previous subscriber node. Okay, so let's actually do these. Let's make these in our my topics. So right now, my topics, if we cd down into source, we list it, we have the topic publisher and the topic subscriber. We're going to create a message publisher and a message subscriber file. So let's touch message publisher.py, and let's also not forget to modify the permissions on it, like that. And then let's open it up in our text editor over here, and I'm going to just take the code from the example book code, copy it, and paste it in here. I think it's a good exercise for you to actually write the code out and understand every line you're using. But for the purposes of this demo, I'll just copy and paste this node there. And the other one we need to create is the subscriber. So we need to touch message subscriber.py and change permissions Great, and now we can open it up in Sublime Text. And I also have open up here so that's the publisher, the subscriber from the textbook example code that we just went through. So we'll just paste that in as well. So there's our new node. And now if we ls, we see we've got our message publisher and our message subscriber there. And notice that they're in green, so that means in our terminal that they are executable. So we have our permissions set on them. We're good to go. So the next thing to do, so we're back up here. Let's try it out. So let's navigate to the workspace root and build the workspace with cat can make. So if I've actually got one open here to the workspace root, so I can just call cat can make. All right, so now we have successfully made our workspace, and we're going to need a ROS core running, which I've already started, so just ROS core enter in a new terminal window. Let's go ahead and source our workspace now in another terminal. So we're in the workspace root, and so we source devel/setup.bash. So now we're able to do our ROS run, my topics, and then we want message publisher. Okay, so that's running. Shouldn't see anything there. Another terminal window, we need to, again, of course, always source our workspace. So devel setup.bash. Good. And now we can ROS run our my topics, message subscriber. Great, and we're seeing real and imaginary numbers that are randomly generated, and they're being printed out to the console at 2 Hertz. Of course, Control C to stop. Great, so we were able to create our own message description and complex, and we were able to change all of our build system settings or configuration by editing our package.xml and our cmakelists.txt. And once we created our nodes, we saw how to bring those custom messages into our ROSPy nodes, and once we had them in there, we fired it up and it worked just fine. So yeah, that's all I've got for you on this.